Roulette. Roulette is a game of chance that uses a wheel that contains 38 numbered slots, as you can see here on the right. The wheel is spun, and a marble is dropped in, and when the wheel stops spinning, the slot wherever the marble lands, that's the winning number. And if you chose the winning number, then you win, and you're paid $35 for every $1 that you bet. Now, what is the expected value of a $1 bet in the game of roulette? Oh, the key word here is expected value. Expected value, that's like the average outcome. The average outcome. Okay, so what we're trying to find here is the average, the mean of this discrete process. It's a discrete process because there's exactly 38 numbers and one of them is the winning number. Okay, so what we're going to do here is set up a discrete probability distribution for the game of roulette. Now, one mistake that could potentially be made is to say, well, there's only two outcomes. You either win or you lose. Okay, so let's say win and lose. Now, the probability of winning and losing, well, what if, let's say it's 50-50. You can either win or you lose. And if you win plus $35. And if you lose your bet of $1. So there's only two things that could happen. If you bet $1, spin the wheel, marble lands, you either win 35 or you lose your bet. Now, if those things were equally likely, then the average outcome would be the average of those two numbers, the average of 35 and -1, in which case we would add them up and divide by 2. 35 minus 1 divided by 2. Well, that's 34 divided by 2, or 17. Well, that doesn't really make sense because you're much more likely to lose than you are to win. So this approach doesn't work. Okay, so what we need to do is, we're not finding the average of two equally likely outcomes. We have to find the weighted average of two unequally weighted outcomes. So let's get rid of this because this approach doesn't work. So let's think about what could possibly happen. Like we just said, you could either win or you can lose. Now, what happens if you win? What happens if you lose? Well, if you win, you have $35. If you lose, that's a -$1. You lose your $1 bet. Now let's look at the likelihood or the probability of each of those things happening. Well, there are 38 numbers. There's only one winning number. Okay, so the likelihood of winning or the probability of winning is 1 out of 38. And the probability of losing, well, there's 37 losing numbers. There's 37 slots where the marble does not land. Okay, so the probability of losing is 37 out of 38. Okay, so in effect, if we take the outcome and combine it with the probability, so we'll multiply those. X times P of X. And this is how we take the weighted average. So the outcome of winning $35 along with its probability, well, that's 35 over 38. And the outcome of losing $1 combined with its probability, if we multiply those two together, we get -37 out of 38. Okay, so putting this together, the weighted average, when we add them up, should be -2 divided by 38. Okay, so that's the weighted average of the two outcomes. And if we'll probably want to convert this to a decimal because we're talking about money, and money is usually given in decimal form, almost never given in fraction form. So if you plug -2 divided by 38 into a calculator, you get approximately -0.05. If we round to the nearest penny, you get -0.05. Actually, 0.05263 something. But the average outcome of a $1 bet, meaning if you were to play this game over and over and over hundreds of times or thousands of times, on average, you would lose about a nickel for every dollar you bet. Sometimes you would win, sometimes you would lose, more often you would lose. But when you took all those wins and all those losses and averaged them all out, it comes out to be about a 5-cent loss per game. Okay, so that's the expected value of the game. The average outcome is the expected value. Now, we took sort of a logical approach. We could have just plugged this into the formula that you would, see in a textbook. So the expected, don't want that color. The expected value of a discrete random variable is the mean. And the formula for this is the sum of x times p of x. This is our formula for expected value. I didn't want to just throw out a formula and plug numbers in because you can't really learn much from that or gain much understanding from that. But essentially, that's what we did. We took each one of these this is x, this is p of x. So this x times p of x, that was this number and this number. And then the summation sign here says add them up. And by doing that, that is essentially finding the weighted average. And the weights, in this case, are the probabilities. So we have the outcome and the weight of that outcome, or the outcome and the probability of that outcome. Okay, that about does it for this problem. I hope this was helpful.